Dr. Amir, you may start.
All right. Assalamualaikum warahmatullahi wabarakatuh and very good morning to all of you. Thank you so much to the MC, Mr. Zainul Luqman. All right, ladies and gentlemen, so we will start with our webinar with a keynote session. So our keynote speaker today is a professor and lead researcher of Center of Biomass Technology in UPM. He is also a fellow of Academic Science Malaysia and a member of the UPM's Board of Directors. So please help me welcome the man who changed the waste into wealth, Professor Dato' Dr. Muhammad Ali bin Hassan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, ladies and gentlemen. My name is Muhammad Ali Hassan. First of all, I would like to thank CiRNeT UPM and also Malaysian Green Tech Corporation for inviting me to this sharing session. Part of what I'm going to present is actually, or a lot of this work is actually joint work between myself and Professor Shirai from Kyushu Institute of Technology and also the Environmental Biotechnology Research Group in UPM, right? And our main funder is actually from Felda over the years. So I would like to share with you the potential of green technology for the new bioeconomy. Some key words on this topic. One is on green technology. So normally when people talk about green technology, people will relate this to low carbon or carbon neutral technologies. In my session today in particular, I will touch a lot on the use of biomass, right, which is the non-food component of agriculture basically, and how do we develop green technology from biomass to support the bioeconomy. And what is bioeconomy? Basically, it is an economic model based on the consumption of biological resources. That's where the word bio comes from. For the production of different products, including food, feed, and also energy. And usually we try to use the non-food as a component as the raw materials, right? And when we say about circular economy, and circular economy is being used more and more nowadays, rather than the linear economy where we use resources and then we throw them away. Circular economy is where we try to use, make them more sustainable. We manage them more sustainably. We try to recover, we try to recycle, we try to reuse as much as possible, right? So in particular, our group tries to focus on providing or promoting circular economy in the rural areas, right? Where we would like to encourage new industries and also new employment for the people in the rural areas so that we can partially stop people migrating to the big cities, right? And here, which is what we are trying to do is we are trying to address all the three pillars of sustainability, namely profit or prosperity, people and planet, right? And in that order, right? So we are going for prosperity or profit first, and then people, and then planet. But of course, we try to marry all these components together, right? But the push must come from profit and prosperity. Okay. So what is the potential? So here I've listed some potential, basically from the ASEAN countries, our neighbors, right, including Malaysia, of course. So what are the resources? Here on the left, you can see so many resources, and then the biorefinery, or basically the facilities where we do the conversion. Of course, we need the technology to start off with, and this is where the scientists and researchers must develop the technologies first, and then we can transfer them to the industry. And at the right-hand side, we can see the potential products, right? To replace the current products that we are using in terms of fertilizer, in terms of energy, in terms of materials, and so on, right? So these are just some of the examples that I've listed here. In terms of bioeconomy roadmaps, Malaysia is one of those countries which has developed our own roadmap, including other countries in the world, of course. And we have got targets, right? So for example, for Malaysia, we are targeting an increase in GDP contribution from 3% to 10% by 2020, and we've passed the 2020 deadline, and we still haven't achieved the 10% mark. So as you can see, there's a lot of potential, and 150 billion is being mentioned here, but in terms of the future potential is even higher than that. Now, coming back to the biomass, the biggest biomass available, which is homogeneous and it's available almost on a daily basis with constant quality, is the oil palm biomass, right? Basically, it's related to the oil palm industry and mainly available at oil palm mills. We would like to use or propose this technology because it is something that has a very big potential in terms of monetary gains, and also it can actually make our palm oil industry more sustainable and greener in the long term. And then also the revenue stream can come from the non-oil part, the biomass part, rather than just from the oil. Okay, and as I said, we go for the 3 P's. So for the first P, which is prosperity, here you can see the value ladder here. So if you cannot do anything else with the biomass, please do not just send it to the landfill where you need to pay for the service. Instead, convert it to fuel, right? Use it as fuel. Convert it to feed or to feed supplements, fertilizer, fiber, furniture, food, and fine chemicals. So as you go up the ladder, the value of the product per ton increase manifold, right? It's just a matter of technology. Do you have the technology or not, right? And is the technology, first of all, viable, right? That's easy. Secondly, is it economically feasible? So we have to prove that, and alhamdulillah, in our research group, we have done much of that, and in fact, I will show later, some of those technologies have actually been commercialized. Our earliest work is actually on methane emission mitigation. Now, methane or biogas is being produced from POMI, or the palm oil meal effluent, basically from the ponds and the tanks, right? And this contribute to very high greenhouse gases emission. 15% of the country's emission is from this source alone, right? And as you know, methane is more than 20 times higher in terms of greenhouse potential compared to CO2. So when you convert methane to CO2, you are basically making it 19 times less in terms of greenhouse potential, right? So our proposal is just to stop this from happening, but you cannot just stop it. You must have a mitigation measure, right? So our mitigation measure is to develop projects with a clean development mechanism under the United Nations. And this project has been actually commercialized by FELDA and TNB in Malaysia, where we have biogas plants side by side with the palm oil mills or the palm oil factory, right? And there we can get energy in terms of electricity 24/7, basically. And we can use this energy to power the new biomass industries associated with the utilization of biomass technologies, right? So here we can get new products. Of course, we can sell these products, and at the same time, we can generate a lot of additional employment for the people in the rural areas. So that's supporting the new economy. So here, in the front here is the pilot plant where we developed the technology in the FELDA Serting Hilir, and later on was being commercialized in 2009 by FELDA. And you can see at the back there, the dome is actually where the biogas, is being captured for conversion to electricity and put to the grid. And in fact, actually the mill can actually use this energy for their own use, but now they are using a lot of the other biomass. So they are selling this to TNB at a high tariff, and it's a commercialized, is a bankable project, right? And since then, I was informed that FELDA has developed more than 12 other such biogas plants. We also develop the fertilizer in terms of compost. So we first have our compost pilot plant in UPM, where we can produce up to 1 ton compost per day, basically from the EFB as well as empty fruit bunch EFB, as well as from the sludge from the treatment ponds.